In this video, we will be talking about molecular models. In science, a model is a representation of a phenomenon or an object or a process or an idea that can't be experienced directly. Models can be physical, like this model of DNA. They can also be on paper or mathematical or even conceptual, like this diagram of a food web. In this video, we'll be talking about several different ways that scientists model molecules. Modeling molecules is very important if you want to really understand them. After all, they're so tiny we can't see them. A molecular model can convey a lot of information very quickly. The most common way scientists model molecules is by using chemical formulas. A chemical formula looks like this. The letters are chemical symbols and represent the elements in the periodic table. For example, the H in this molecular formula stands for hydrogen and the O stands for oxygen. Since this molecule has two different elements in it, it's a compound. The number, which we call a subscript, tells us how many of each atom we have. The subscript 2 on this water molecule tells us that there are 2 hydrogen atoms in this compound. Oxygen does not have a subscript. If there's no subscript, it means there's only one atom of that element in the molecule, so each water molecule has only one oxygen. Here's another example. Consider the molecule glucose, C6H12O6. It has atoms from 3 different elements in it, so it is also a compound. The C stands for carbon, the H stands for hydrogen, and the O stands for oxygen, and these chemical symbols are in the periodic table. From the subscripts, we see that we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms in the molecule. If we want to total up all the atoms, we can just add the subscripts together. 6 plus 12 plus 6 equals 24 atoms. Here's the formula for molecular oxygen. Oxygen is an element, but in nature, we usually find it in this form, with 2 oxygen atoms bound together. It's a molecule, which is why we call it molecular oxygen. But because there is only one type of atom in this molecule, we call this an element, not a compound. The subscript 2 tells us that there are 2 oxygens in this compound. Another type of model is the ball and stick model. Ball and stick models are 3-dimensional models where atoms are represented by spheres of different colors. Bonds are represented by sticks between the spheres. Different atoms are usually associated with different colors. For example, hydrogen is typically white, and oxygen is typically red. You may notice that sometimes there will be one stick between 2 atoms. This represents something called a single bond. If there are 2 sticks, this represents a double bond. And if there are 3 sticks, this represents a triple bond. Although we often see ball and stick models on paper or in computer simulations, we can also build them using plastic balls and sticks. Space-filling models are another way to provide a 3-dimensional representation of a molecule. Just like in the ball and stick models, the atoms are represented by spheres. But there are no visible bond lines between these atoms, and the atoms are placed on top of each other to show that they are bonded. The sizes of the atoms are represented by the sizes of the spheres. Larger elements are modeled using larger spheres. Smaller elements are modeled using smaller spheres. Computers are often used to make 3D space-filling models. Here is another model called a structural formula. Structural formulas are a little like ball and stick models, except that instead of atoms being represented by spheres, they're represented by the symbol for the element. Of course, these are not the only ways to model molecules, and there are a few others, but these are some of the ones you will see the most often. In summary, there are several ways to model molecules, and these include chemical formulas, ball and stick models, space-filling models, and structural formulas. These models can help us better understand the structure of molecules.